Problem 111, we're taking a look at some expressions, and we need to give answers that do not have negative exponents or fractional exponents. So the first problem we take a look at here, problem A, 5 to the negative second times 4 to the 1/2. First of all, taking a look at this part of it right here, we have a negative exponent. A negative exponent means that we need to use the reciprocal of this number, and it becomes a positive exponent. So that becomes 1/5 to the positive second. A fractional exponent, right here, when we deal with that, we're taking that root, so the second root, or the square root, and it is then put to that power. So this can be rewritten as the square root of 4 to the first power. And we don't necessarily need to have this first power here. Everything is to the first power, so that can actually just be taken off. So taking a look now at this part and simplifying this, I'm squaring both the numerator and the denominator. So my numerator is 1 squared, and my denominator is 5 squared. Times square root of 4 is 2. This ends up equaling then 2/25 when I multiply those together. Problem B. This one has a lot of information in it. So if I take a look at just my negative exponents right now, remember that z to the negative second is the same thing as 1/z to the positive second, which essentially means my negative exponent now moves to my denominator and becomes a positive exponent. Very similar thinking here with this one. If I have x times y and that entire thing is to the negative first, to make it a positive exponent, I use the reciprocal, which moves it back to the numerator. So I'm going to rewrite this problem by just doing nothing else but getting rid of my negative exponents. So I've now rewritten this, taking this now in the numerator, and my z squared is now in the denominator, and I have all positive exponents. So now simplifying this, my numerator, I have a 3. I also have an x times an x to the first, which is going to be x squared. I then have a y squared times a y to the first. That's going to be y to the third. And I have z squared times z squared in my denominator, which will be z to the fourth. And that is now simplified as far as it can go, with no fractional exponents and no negative exponents. Problem C. I'm going to first of all take a look at this problem here, and we have negative exponent there and we have fractional exponent there. So I'm going to rewrite it with that information. So if I rewrite this, that negative exponent goes in the denominator, and I should here have a positive exponent. I just took that negative away. So there's a positive exponent. My fractional exponent, the denominator of that fraction, is the number of the root that I'm taking. So I'm taking the third root, and the numerator of that fraction is what I'm doing. I'm squaring this then. So now I can simplify this even further. So this part right here, I am putting 3 and m squared both to the third power. So 3 to the third power is 27, and m squared to the third power is m to the sixth. For this section right here, I'm taking the third root of 8, which is 2. and the third root of n cubed, which is n. Both of those are still being squared. My denominator is now 2mn. This can be simplified once again even further. If I just get rid of my parentheses here, so I'm squaring the 2 and squaring the n, I have 27 m to the 6th times 4 n squared divided by 2mn. Now I need to simplify. 27 times 4 divided by 2 is going to end up equaling 54. Now when I take a look at m to the 6th divided by m, I'm going to be left with m to the 5th. And when I have n squared divided by n, that simplifies down to n. And there is my simplified answer for problem C. The last one on problem D. We have a 1/3 exponent, so I am taking the third root of 5x squared y to the third z. And then the numerator is a 1, so this all would be to the first power. Again, we don't need to write that. So the third root of all these, if I take the third root of 5, doesn't really simplify anything. Same thing with the third root of x squared, doesn't simplify. However, I can take the third root of y to the third. That is y. And the third root of z does not simplify. So the rest of it needs to stay under the radical, so I'm taking the third root of 5x squared z. So it is y times the third root of 5x squared z. That is the simplified answer.